Hello and welcome back to Dr. Logic awkwardly does logic in her kitchen. Now, back to actual logic. A couple videos ago, we were talking about variables, and I made this big fuss about the distinction between free occurrences of variables and bound occurrences of variables. And you might be forgiven for sitting here wondering, what is the point of all of this? Well, I'm going to start motivating why we have this distinction and what we can do with it. It's going to be part of what gives us the expressive power to be able to say things in predicate logic that we can't say in propositional logic. The idea is we want to be able to introduce a notion of substitution. So, where we have suppose you have a general statement that says, all cats like to sleep in front of fires. Well, that's a general statement, and it's talking about cats generally. But maybe we want to be able to move from that statement, which you can think of as saying, for any object, if it's a cat, then it likes to sleep in front of a fire. Well, instead of just saying something about any object like that, maybe we want to talk about individual cats. So maybe we want to be able to say that from the fact that all cats like to sleep in front of fires, that Neff likes to sleep in front of fires, and Goldie likes to sleep in front of fires. The way that we will be able to do this at the syntactic level, so at the level of writing out strings of symbols, is through substitution. The idea is some of the variables in our formulas may occur freely, and the ones that do, you can always swap out those variables and put something else in their place. Now, that something else can be any other type of term because remember, variables are terms. So you could replace it with another variable or maybe a constant that picks out an individual object, for example, Neffy, or you could substitute in a function applied to certain terms because this also picks out an individual object. So I could say, the shoutiest cat in my house likes to sleep in front of the fire. So the shoutiest cat in my house is a function which picks out Neffy, but doesn't name her explicitly. So this is the idea of what it is that we're going to be doing, but substitution is very much a syntactic notion. It's all about how do we take strings of symbols and change them into other strings of symbols. This will end up having meaning once we get to the point where I'm actually teaching you semantics, but there's a whole bunch of machinery to get through before we reach that point. Now, let me bring up the whiteboard to just kind of give you an example of what this sort of thing would look like. The general idea is suppose that we have some formula phi that has x possibly occurring freely. So it might either not occur at all or all the occurrences might be bound, but maybe it is possibly occurring freely. And then we want to develop a way of generating a new formula, which we will call phi tau slash x, which is the result of substituting tau in for the free occurrences of phi. So this will all get made more explicit when we give the formal definitions in the next video. This is just kind of introducing it to you. So this is the result of replacing all free occurrences of variable x in formula phi with term tau. That's how you can read this notation. So consider the formula. So let phi be exists x, ryx. In this case, our occurrence of x falls within the scope of this quantifier. So on the rules that we will define, the result of, say, substituting the constant a in for x is just going to end up being the same. But now suppose that we have another formula, phi prime, which exists y, ryx. Then this x is free, because it's not in the scope of any quantifier that binds it. So ultimately what we're going to want is we're going to want to have our definitions be such that the result of substituting A in for any occurrence of any free occurrence of X would get us systs Y, R, Y, A. Now, the reason that we will, in this case, X is just kind of hanging out there. I haven't told you how to read sentences that have kind of free variables like this, but let's think of something a bit more natural. For instance, for every object, if it is a cat, then it likes to lie in front of a fire. What we will be doing with substitution instances is saying, okay, let's ignore the quantifier for a moment and then essentially say, okay, we know that this X can be anything. So what happens now if I do a substitution instance? Well, I can get something like, if Neff is a cat, then Neff likes to lie in front of the fire. But just as equally, I could have gotten that if Goldie is a cat, then Goldie likes to lie in front of the fire. Even more precisely, I could do something like, if Sarah is a cat, then Sarah likes to lie in front of the fire. Now that's a true sentence, even if I am not a cat, simply because I like to lie in front of the fire. Anyway, this is all very much just kind of motivation and explanation, kind of giving you a view towards what it is we will be doing with substitution before we actually start defining it explicitly. But we'll save that for the next video. Take care and see you then.